Okay, in recent Gresty Academy videos, we've been looking at how to evaluate sine to the power of n theta d theta for any n being odd, and today we're going to look at the corollary to that, which is integrating sine to the n theta d theta for any even n. And what we're going to do is we're going to use two results that we've already established from the Gresty Academy video, de Moivre's theorem, which are z minus 1 over z, where z equals e to the I theta. Z minus 1 over z equals 2i sine theta, and z to the n plus 1 over z to the n equals 2 cos n theta. And if they don't mean anything to you, please go and watch our video on de Moivre's theorem. But if they do, we can continue. So what we're going to do, first of all, is give you the general rule, and this method works for every single even value of n. And we'll do the example of sine to the power of 8 theta later on. But first of all, let's just have a look at very generally. So what will happen is that we are going to use, first of all, we're going to use this formula here, z minus 1 over z equals 2i sine of theta, and to whatever power of n we're looking to integrate sine to the sine of theta, we will raise both sides to the power of that n. Okay, and that will give us our sine theta on this side, and this, when we expand it, we will find that we get z to the n, and I'm not going to do, because obviously it depends on what n is, and then we're going to get z to the n minus, using combinatorics here, so n to the 1, z to the n minus 1 times 1 over z, add n2, oops, excuse me, add n2, z to the n minus 2 times 1 over z squared minus n3, blah, 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 blah. And what we will do, and the last term will be 1 over z to the n. And what we will find, and we will see this with the example sine to the power of 8 theta soon, is that we will then be able to pair z to the n add 1 over z to the n, and we will pair z to the n minus 2 and 1 over z to the n minus 2. That will be this one and the one which is just over there. And we'll be able to pair z to the n minus, sorry, z to the n minus 4 and 1 over z to the n minus 4. We will then replace these terms here using this second equation with cos n theta, which is then extremely easy to integrate. That's the theory, and because n is even, we know that we will get exactly n over 2 of these pairs, all of which will be cos of n theta, or n over 2, or n minus 2 theta, and then it's very easy to integrate. So let's go with an example. Let's take the integral of sine to the power of 8 theta d theta. Okay, so we're going to use z minus 1 over z equals 2i sine theta, and then we're going to raise it both sides to the power of 8 because that's what we want to integrate. Okay, and now we're going to expand z minus 1 over z to the power of 8, and if you don't understand the method that I'm about to use, please watch the Gresty Academy video, how to expand a plus or minus b to the n quickly, because it is very simple to expand this using that method, and that is going to give us, right, so that's z to the 8 minus 8z to the 7 times 1 over z, add 28 z to the 6 times 1 over z squared, minus 56 z to the 5 times 1 over z cubed, add 70 times z to the 4 times 1 over z to the 4. And just what we're doing here, just very briefly, this is term 1 and this is term 2, and we're using Pascal's triangle here, and we're just alternating the minuses and the plus because that is a minus. So let's carry on. Sorry, so that's 70z to the 4 over whatever, minus 56z cubed times 1 over z to the 5, add 28 z squared times 1 over z to the 6, minus 8z times 1 over z to the 7, add 1 over z to the 8. And then, as predicted, we will find that we have these pairs. So there's the first pair, here is the second pair, and we can now rearrange this as, so we're going to have 2 to the 8 I to the 8 sine to the 8 theta equals z to the 8 plus 1 over z to the 8, and all I'm doing is rearranging this here by pairing all of the z to the 8. So then minus 8 z to the 6, add 1 over z to the 6, which is this one and this one. And then add 28, brackets, z to the 4, add 1 over z to the 4, which is this one and this one. And then the next one is minus 56 z squared, add 1 over z squared, which is this one and this one. And that just leaves us with one more, which is this one on its own, which is plus 70. So we now have the equation almost in the form where we can integrate. So let's have a look now. 2 to the power of 8, let's just leave that as 2 to the power of 8. I to the power of 8, well, I to the power of 4 is 1, so I to the power of 8 is also 1, times sine to the power of 8 theta, equals, now, z to the 8 plus 1 over z to the 8, using our formula here, will be 2 cos 8 theta. So we can replace that by 2 cos of 8 theta minus 8. This likewise will be 2 cos of 6 theta. Add 28. This will be times 2 cos of 4 theta minus 56 times 2 cos of 2 theta. Add 70. So we now have this equation here, and we can now get sine to the power of 8 theta equals, we can divide everything through by 2 just to make it slightly easier, 1 over 2 to the power of 7 times cos 8 theta minus 8 cos 6 theta, add 28 cos 4 theta minus 56 cos 2 theta, add 35. Okay? So now that we have that, we can now integrate, which is what the whole point of this video is. We integrate sine to the power of 8 theta d theta is the same as the integral of this d theta. And integrating cos of n theta is a simple matter because the integral of cos of n theta d theta equals sine of n theta over n plus a constant. So it's actually very simple now to integrate. So we have the integral of sine to the power of 8 theta d theta equals 1 over 2 to the power of 7. And we're going to integrate each one of these terms. So that gives us sine to the 8 theta over 8, which is the integral of cos 8 theta, minus 8 sine of 6 theta over 6. Excuse me, where am I? Add 28 sine of 4 theta over 4, that's integrating this, minus 56 sine of 2 theta over 2, and add 35, well the integral of 35 is 35 theta. And that is our answer. So the integral of sine to the 8 theta d theta is 1 over 2 to the 7 sine 8 theta over 8 minus 8 sine 6 theta over 6, add 28 sine 4 theta over 4 minus 56 times 2 theta sine 2 theta over 2, add 35 theta, plus of course the constant of integration. Now you will find, regardless of what n is, as long as n is even, you will get pairs that match up like this when we expand, and so you will end up with a bunch of cos n theta, cos n minus 2, cos n theta, cos n minus 2 theta, cos n minus 4 theta, a bunch of them. You will integrate them using this simple formula here. The integral cos n theta is sine n theta over n, and voila, you have your integral of any sine to the n theta d theta for n even.